Hi, my name is Raghu Tirumalai. I'm a scientist at the Center for Cellular and Molecular Biology in Hyderabad. The work we do focuses on a disease called tuberculosis. And tuberculosis is a very ancient disease, and it's a killer disease. And it's been known since ancient times, and evidence for tuberculosis has been known since the time of the ancient Egyptians. So the problem is, or the unfortunate thing is, despite the advent of modern medical technology and medicine, we still haven't been able to find a cure for this disease, and until this day there are close to 1.5 million people dying of tuberculosis every year, and most of these deaths occur in what we call as the developed world: India, China, Southeast Asia, large parts of Africa. So it's essentially a poor man's disease. In addition to the losses of life that it causes, it's an incredible burden for countries in terms of loss or cost in socio-economic revenue. So it not only kills people, it destroys families because of the the torture that families and patients go through. And the additional complication is that now we have something called drug-resistant tuberculosis. Okay? Now, initially, we had found drugs for tuberculosis. You could treat them. If a patient was diagnosed quickly enough, they could be treated with a 4-drug cocktail, and if they managed to complete the regimen, they would be cured. But the problem with the treatment is it is long, sometimes 6 to 9 months, and the symptoms go away after about a month, and people stop taking the medicines, and this leads to the development of strains of the bacterium that causes tuberculosis to become resistant to drugs. And then if somebody gets drug-resistant tuberculosis, that requires a much longer and more painful regimen for treatment. So Mycobacterium tuberculosis, the bacterium that causes tuberculosis, is a very, very smart bug. And the challenge for people like me who work on this disease is to figure out the basic biology of this pathogen, a very, very successful pathogen, one of the most successful pathogens ever known to man. So we in the lab study the basic biology of this bacterium, the pathogen, and we hope that studying the biology will give us insights into mechanisms of how this bacterium causes disease, and perhaps we could use this information to design better therapeutic approaches, better vaccines, or better reagents for diagnosis. Being a scientist is, I think, about being curious. So whenever a student joins my lab and I ask them, why did you join? I'm happiest when they tell me that I want to do research because I'm a curious person. And as scientists, we like asking questions, we like designing approaches to be able to answer those questions, designing experiments, analyzing the data, and then moving on to the next experiment. So every day brings something new. It's unpredictable, it's tough, it's challenging, it's hardworking, it's gut-wrenching. But once you're able to answer the question that you were trying to answer, it's extremely fulfilling. And for me personally, the favorite part of being a scientist or a teacher or a mentor is when my students complete their training with me, they go out and they are, in quotes, successful, and they do well for themselves, and they come back and tell me, Raghu, you really made a difference in my life, and training with you has made me a better person, has made me a better scientist, has made me a better individual. And for me, that is the greatest reward in being a teacher and a scientist.